So we will continue with Cartesian coordinates. Cartesian coordinates. I will talk about in Cartesian coordinate. We will talk about the unit vector. Let me draw my Cartesian coordinate system. I'm having a Cartesian coordinate system like this. I can call this Y, X, and Z. So I have something here like J, a small j. I have something like a small I and a K. I have something here like 0. This Cartesian coordinate have unit vectors I, J, and K, and the magnitude of the unit vector their magnitude we represent magnitude with a double bar. Their magnitude are equals to 1. Now I'm going to go directly to the decomposition of vectors. Decomposition of vectors. I'll just use this Cartesian coordinate system. If I have a vector, let me call this vector. I call this a vector F. The direction here, theta. This F is in the reference f of x, f of y, and f of z. So I have to know this. I have to look for f of x, f of y, and f of z. And you should know that this is still equals to, you can write it like this, f of x plus f of y plus f of z, or using the unit vector f should be equals to fxi. Now put fxy, this is j, plus fz, sorry, I don't have to put an arrow here, this was f, and now in the k I have an arrow, so it is all the same. It can be written like this, or like this. So now let me start by a coordinate plane having x and y to decompose x. Let me have this y, this x, and I need to decompose my vector f. This vector f can be called a force. No, force are vectors quantities. Velocity are vector quantities, and acceleration, those are vector quantities, because we have both magnitude and direction. Now this is my angle. So many students have problem in decomposing vectors. So I'm going to explain it very, very well here, please. You can pay attention. Now, this is my Cartesian coordinate system. In this system, I have x and y and a vector f. So my problem first is to look for f of x. Now, if you can see, I can have something here like my y is still the same. I can have something here like my x. Let me call it y prime. I call this an x prime. Now, there's a way that I'm going to show you very, very carefully. Just look at it. I'll write something here like so, ka, toi. In this equation, I have sine is opposite over hypotenuse. Cos is equal to adjacent over hypotenuse. And tan theta is equal to opposite on adjacent. So now, if we look very carefully, let me start by the first. I have sine of this angle should be equals to what is my opposite? My opposite of this angle is y. Y on hypotenuse. My hypotenuse is the longest side, which is f. So now what's my y? My y is equals to f sine theta. Now, that's the y coordinate. Now, let me talk about the x coordinate. So I'll see now that I'll continue here. I have cos is equal to adjacent over hypotenuse. My cos of this angle is equals to what's my adjacent of the angle? The adjacent of the angle is x over my hypotenuse, which is f, which means x is equals to f cos the angle. So now my force F, I'll have F, I'll have F cos theta in the x direction, F sine theta. Many students always have problem here. I'll continue with the decomposition. Let me draw another frame of reference. Please, you look very carefully. My vector will be in this direction. I call this my y, call this my x. It should be minus x. But we know this in the negative direction. And this, my f, this is my angle. So I'm going to follow the same principle, but you will discover that I'm going to have a negative sign somewhere. I start, just take my parallel y coordinate. I call it as my y prime. Now, I call this as my x prime. Following the rule of Socrates, sine of the angle is y is opposite on hypotenuse, y on f. Now I'm going to have y will be equals to f sine theta. But you will discover that when I stroke this my y downward, it's going to touch the x in the negative direction. So you will discover that it will be equals to minus f sine theta, because it has strike the axis in the negative, the x-axis in the negative direction. Please take note of this because most students face difficulties. Now I'm going to take my cos. My cos, which should be equals to the adjacent. Adjacent is x over f. X should be equals to f cos theta. When I take my x, I strike it in the y-axis, it's going to strike it at the positive direction. So it is okay like that. So my f, my force f will be f cos theta in the x-axis and f sine theta in the y-axis. So this is how we decompose forces. So your sense, they can give you to decompose this force, giving you this angle. Let me call this alpha. You have to still be able to decompose that force using an angle alpha, and it is going to be different from this. Many students face more difficulty. So in our next class, I'll throw highlights on how to decompose forces. Again, they will continue with coordinate systems in spaces, vector system in spaces. Thank you for watching Quentech video. Thank you for watching.